And there is a bell to start this video. Fabulous. And that means in 5 minutes there will be another bell, plus probably somebody interrupting me as I make this cold vision. This is one of the homework problems somebody asked me to work. And we can see what we've done. It's a little bit more complex series and parallel. And if you don't understand how to work this one, then that's what we're going to try and explain in this video, is exactly how to do this problem. So let's see if we can't kind of work this one out. Alright, my priorities, even on this more complicated one, it's just like when you learn the basic ones. I want to find 3 things to start every single circuit problem. I want to find V total, R total, and then third, I want to find I total. I want to find my total potential, which in this case is easy. I've got a 20 volt battery in here. So I've got a 20 volt battery. I want to find R total, which is going to be a little bit more confusing because I've got 1, 2, 3, 4, 5 resistors, and I want to find I total. So I want to try and find R total first in this problem. Well, here's what you've got to do. You've got to look at this problem and look at this 10 and this 20. This 10 and this 20, how are these two related to each other? Well, these two are in parallel to each other. And since they're in parallel to each other, this 10 and 20 can be reduced by adding up like this. 1 over 10 plus 1 over 20. But don't forget, when you do this, 1 over 10 plus 1 over 20 equals 3/20. Don't forget, take a reciprocal. X negative 1 equals 6 2/3, which is 6.6666666. So this is 6.67 ohms. What that means is that you see I've got these 2 resistors up here. I could replace those 2 resistors with a single 6.67 ohm resistor. So I'm going to write that down in the middle. So in other words, I could replace those 2 resistors with this little resistor right here. So, alright, hopefully you got half that idea. By the way, I had somebody ask what exactly a resistor even looks like. And I got the feeling bad. I was like, you're doing resistor problems and you don't know what a resistor looks like. So if you haven't done a lab or anything yet, there's what a resistor looks like. It's this little color-coded thing. So this represents a 10 ohm in this picture and a 20 ohm, which this is more like 330 or something like that, a red, orange. I cannot remember what a red, orange is at this point. But anyway, so you're kind of getting a little bit of an idea. So I've got 2 resistors, reduce them. 1 over 10 plus 1 over 20, that's 6.67. Go over to here. These 2 are also in parallel. So I can reduce these 2 by adding them up. 1 over 60 plus 1 over 100. Don't forget to take a reciprocal. So I'm going to do the same thing. 1 over 60 plus 1 over 100. 2/75. I'm going to hit my reciprocal button. If you don't have a reciprocal button, you could just go 75 divided by 2 and get the answer. So reciprocal of that is 37.5. So 37.5 is what I'll write. That means I could replace both of these 2 resistors with a single 37.5 ohm resistor. Now, if you're not following me, what I'm saying is this. I could redraw this entire problem right now to look like this. Look at this. Here we go. Redrawing. Instead of a 10 and a 20, 1 over 10, 1 over 20, I could replace the 10 and the 20 with a single 6.67 ohm resistor. Now, keep going. I've still got that 50 right here. So I've got my 50 ohm resistor here. And now I'll keep going. Instead of a 60 and 100, I can replace both of those resistors with a single 37.5 ohm resistor. Now, compare the problems. I've got a 20 volt battery. Look at this. I've taken this complex looking problem and I've turned it into this. Just a straight series problem. If I want to reduce a series, all I've got to do is R1 plus R2 plus R3. If there was 40 of them, I'd add all 40 of them together. But in this case, I'm going to add those 3 resistors together, and that's going to be my R total. 6.67 plus 50 plus 37.5 equals 94.17. I'm going to be kind of lazy. I'm just going to write 94. So that means I could find, you talked me into it, 94.2. There. There. It means what we could do is this. 20 volts. We could replace this entire picture of 5 resistors and in its place put a single 94.2 ohm resistor in this problem. Well, that's not too hard at all. I think I've kind of got this. So now I know my R total. My R total is 94.2. And if I know R total, that means now I can get I total. So I know that V is equal to IR. It's the only equation I'm going to use. The rest of this problem, every other question, I will use that formula to answer. So I'm going to use 20 equals I times 94.2. Let's see if I can't figure this out. 20 divided by 94.2, 0.21 amps. So I've got 0.21 amps leaving the battery. That means leaving this battery, and I can go anywhere. I can go to this problem. That means I've got 0.21 amps leaving the battery. That means I can go to here. I've got 0.21 amps leaving the battery. So I want to follow that 0.21 amps. And if you can learn to follow this 0.21, you can work any question. Now, let's go all the way up to this main picture. I've got 0.21 amps, and here it's coming. This is a measure of your current, of your electricity. It's going to get to this junction, and what's going to happen? It's going to split. Part of it's going to go that way, part of it's going to go this way. But overall, I've got, watch this, I've got 0.21 amps in this problem. So no matter how it splits, the total is still 0.21. So how many amps go through here? 0.21 amps. I want you to notice something. 0.21 amps. How many goes through here? Once again, 0.21 amps. And then leaving is 0.21 amps. So in other words, I'm trying to get something across. If you did a problem and you had like 300 resistors in it, and they were all in some kind of a big row, bam, bam, just draw me some big old hillbilly size resistors here. Look at these things. No matter what you, wow, that one was terrible. But no matter what you got, once you figure out what this I is, let's say that I is 4 amps. If I is 4 amps, that means it may split up, but you would have 4 amps in here. It would come back together. And again, it might split up, but you would have 4 amps flowing through there. And that's what we're looking at in this picture. I wish I'd drawn it even huge, like gigantic size. But each section of this has got 0.21 amps going in. Now, here's the thing. That battery that we've got, that battery, and I didn't draw this in here, but it's losing something. This battery is losing over each single section. I'm going to write V1 here. It's losing volts over this section. This battery is also losing volts over, it's using up its potential. It's using up volts over this section. And then, well, you got to think, if it's dropping volts over this, dropping volts over this, then this third section, it's got to be dropping volts over it as well. So it's losing voltage or losing potential over every single section of this. So here's what I want to kind of do now. Can I find V1, V2? If I had 20 of these, I'd do it the exact same way. Can you find the volts being dropped over each one of these pieces? Well, I think I can. Let me grab another sheet of paper. You see, there's this guy told me. He said, when we get R total, the only equation we need to use is V equals IR. So wait a second. So to find V1, I'm going to use IR? That's right. To find V2, you mean I'm going to use IR? That's right. To find V3, I'm going to use IR? Yeah, that's right too. You see, here's the thing. If I want to find V1, what is my amps going through here? Yes, I know the amps are splitting, but it's 0.21. I've got 0.21 amps in the first section. Wait a minute. How many amps are under V2? 0.21 amps. Wait a second. I'm noticing a trend. I love trends. Wait a second. It can't be V3. V3, how many amps are going through here? 0.21 amps. Notice something. The whole problem, 0.21, 0.21, 0.21. Now this is the spot where people mess up. What is the resistance for V1? Is it 10? Is it 20? Remember, you could replace that 10 and 20 with a what? 6.67 ohm resistor. What about V2? Well, V2 is easy. It's 0.21 times 50. It's right there. Hey, I like that one. That one's pretty straightforward. Well, the other one can't be that easy, can it? 0.21 times 60 times 100. No. Remember, the 60 and the 100 could be replaced by a 37.5. So it's going to be 0.21 times 37.5. And if we had 40 resistors, we would keep working this exact same way. Now I'm just going to go through here and work this one out. 0.21 times 6.67. So that's 1.40 volts on the first one. So 1.4 volts are being dropped on V1. What about the next one? 0.21 times 50. 10.5. So I'm losing 10.5 volts over the next section. Well, I only had a 20 volt battery, so I can't bust that. 0.21 times 37.5. 7.88 volts. So what it tells me is this. I'm losing this problem. I'm losing 1.4 volts of potential over this first section. Why am I losing my least amount of volts over this section? Because it's got the least resistance. I'm losing 10.5 volts over the second section. Keep going. Over third section, I'm losing 7.88 volts. I'm finding out every possible thing I can find. Now wait a second. Somebody is wanting me to go back and figure out what happens when this electricity splits. They're wanting an I2 and an I3. Doggone them. Look at all these questions they're asking me. Hey, I'm not going to freak out too much. The reason why is this. This problem asks me to find I2. No problem. What's the only equation I need? V equals I2R. If I want to find I3, what equation will I use? V equals I3R. If I want to find I4, V equals I4R. I5, V equals I5R. It's kind of a trend. You notice that? The only thing you can do to mess yourself up is this. What are you going to use for V for I2? Most people mess up because they use 20. You don't have a 20 volts being dropped right here. How many volts? This is why we did this, V1, V2, V3. Even if it don't ask me to do V1, V2, and V3, I'm going to go find V1, V2, and V3. I'm losing 1.4 volts on this section. So if I want to find I2, it's going to be 1.4 equals I2 times R. The R is, what is I2 going through? I2 is trying to force its way through that 10. So I'm going to write a 10 right there. Well, that's going to be easy. That's 0.14 amps. So I've got that one. Matter of fact, I'm going to do a little bit in my head. If this is 0.14 amps going through the top, in other words, you just figured that there's 0.14 amps of electricity going through the top of that circuit. You've already told me that there's 0.21 going through the middle of it. So how many amps must be going through the bottom of the circuit? Wait a second. It's got to be 0.07 amps. And lo and behold, I3 would be 0.07. Hey, we can do the same thing down here. How do you find I4? I'm getting papers falling all over the place. If I want to find I4, what formula am I going to use? Wait a second. I'm going to use V equals I4R. What am I going to use for V? Ignore the rest of the problem. If I want I4, all I'm looking at is this piece of my puzzle. My V is 7.88. So my V is 7.88. I4. R is, I'm trying to push this through a 60. Let's grab that calculator. Smell some of that Chef Boyardee stuff. That's good stuff right there. Health food. 7.88 divided by 60. 0.13. Now we can go back and use some common sense again. You just found that going through the top of that resistor is 0.13 amps. We know that going through the whole thing is 0.21 amps. So how many amps have got to be going through the bottom half of the circuit? Here is I4. Here is that I5 then that won't. If you want to prove it, you can prove it. I5, we could use V equals I5R. 7.88 divided by 100 be 0.0788, so 0.08 if you round it off. Y'all, that is every possible question somebody could ask you about that. Thank you, and